So welcome students. In this video, we are going to look at how we perform operations between two complex numbers. That is, how we add two complex numbers, how we subtract one complex number from the other, how we multiply two complex numbers, how we divide two complex numbers. So these are the four important operations that we are going to study. So first, let us go for addition and subtraction. This is quite easy. Let us take an example. So if you have a complex number z1 is equal to 2 plus 3i, and if you have a complex number z2 is equal to 5 minus 4i, and if you are asked to add z1 to z2, so if you want to add z1 and z2, if you want to add two complex numbers, the process is add real parts separately, add imaginary parts separately. So add real parts to real parts, add imaginary parts to imaginary parts. So you have 2 plus 5, this is a real part, this is a real part. If you want to add z1 and z2, 2 plus 5 is 7, 3i minus 4i is simply minus I. So add real parts separately, add imaginary parts separately. So the real part is 2 plus 5, the imaginary part is 3 minus 4 is minus 1 times I. If you want to do z1 minus z2, again the same process, you subtract the real part separately, the imaginary part separately. So 2 minus 5 is minus 3. So if you want to subtract it, just put something like this. So 2 minus 5 is minus 3. 3 minus of minus 4 is nothing but 3 plus 4. So it is minus 3 plus 7i. So this is as simple as this. If you want to add or subtract, consider real part separately, consider imaginary part separately, do the operation that gives you the answer. So next, let us look at multiplication in complex numbers. So there are two types of multiplications. So first is, if you want to multiply a complex number with a real number. So here also let us consider examples. So if you want to multiply a complex number 2 plus 3i with a real number 5. So if you want to multiply these two, so it is exactly same as a bracket expansion that you do in normal number theory. So 5 times 2 plus 3i can be written as 5 into 2. So you multiply this with real part as well as the imaginary part. So 5 into 2 is equal to 10 plus 5 into 3 is 15. 5 into 3i is 15 times I. Next, let us take an example. 5 minus 6i. So if you want to multiply this complex number with something like 7. So if you want to multiply this complex number with a real number 7. So again you do the multiplication as we do bracket expansion. So 5 into 7 is equal to 35 minus 6i into 7 is minus 42i. So that means if you have a complex number and a real number, so you multiply the real number with both the real part as well as the imaginary part. And the next type of multiplication is if you have two really complex numbers. That is, if you have 2 plus 3i times 5 minus 2i. So how do you multiply these two complex numbers? So again, this is exactly same as the bracket expansion that we do in normal algebra. So 2 into 5 is equal to 10. 2 times minus 2i is equal to minus 4i. 3i times 5 is equal to 15 times I. 3i times minus 2i is minus 6i square. So you have 2 terms into 2 terms, so you have a total of 4 terms. So that is equal to 10. So if this has been converted into addition, some sort of addition. So 10 minus 4i plus 15i. These two are the imaginary parts, so we deal them. So 15i minus 4i is 11i, and 6i square is not imaginary because I square is equal to minus 1. So 6 times minus 1 is plus 6. So that is equal to 16 plus 11i. So let us take another example. 5i minus 2 times I plus 7. So if you want to multiply these two, again, as you do bracket expansion, 5i times I is 5i square. 5i times 7 is 35 times I. Minus 2 times I is minus 2i. Minus 2 times 7 is minus 14. So that is equal to. So now these two are the imaginary parts. So 35i minus 2i is 33i. And I square is minus 1. So 5i square is minus 5. Minus 14 is, so minus 19 plus 33i is the answer. So here you need to be careful about I square. So you should not write I square as plus 1. You should write I square as minus 1. So if you remember that, the remaining else, everything is as you know already. So now that you have understood how to do multiplication, let us see how to do this operation fastly. So let us take another example. So let us take 5 minus 2i times 3 plus 4i. So we know that the final answer will be of the form some real number plus I times some other real number. So in this multiplication, you have 4 terms. So you can write the 4 terms and simplify it. But otherwise, if you want to do it fastly. So what you can do is, so what are the multiplications which give you real parts? So real into real gives you a real number. I times I will also give you a real number. So this part and this part gives you real parts. So what is the real part? 15 minus 8i square. 15 minus 8i square. I square is equal to minus 1. So 15 plus 8 is equal to 23. So this and this gives you real parts. So do that separately. Now if you want the imaginary part, so if you take real here and imaginary here, this gives you an imaginary number, and imaginary here and real here, this gives you an imaginary number. So 5 times 4i, 20i. 3 times minus 2i, minus 6i. 20i minus 6i is 14 times I. So if you practice multiplication like this, so it will be over very easily in one step. So let us do another example in this process. So I minus 5 times minus 4 minus 2i. So that is equal to. So now if you want the real part of this, multiply real with real and imaginary with imaginary. So you get the real parts. Minus 5 into minus 4 is 20 minus 2i square. Minus 2i square is plus 2. So 20 plus 2 is 22. What is the imaginary part? So I into minus 4 is minus 4i. Minus 5 into 2i, minus 2i. Minus 5 into minus 2i is plus 10i. So minus 4i plus 10i is 6i. So it's as simple as this. So as you have seen in multiplication, if you multiply a real number with an imaginary number, so that real number just goes inside and multiplies with the both real part and imaginary part. So you can also do that in a reverse way, something like this. So if you want to multiply, for example, 35i minus 35 minus 7i into 42 minus 21i. So if you want to multiply these two, you don't need to multiply all these big numbers. So what you need to do is, so 35 and 7, can you see that both have 7 in them? So I can take a 7 as common, because 35 minus 7 I can be written as 7 times 5 minus I into, so in this 42 and 21, can you see that 21 is common in these two? So if I take 21 outside, so you get 2 minus I. So that is equal to 7 into 21, like 147 times 5 minus I times 2 minus I. So now you can multiply these two very small complex numbers. That is equal to 147 times, so 10 plus I square, that is 10 minus 1 is 9, minus 2i minus 5i is minus 7i. So the multiplication of these two is 147 times 9 minus 7i. So this is a very important technique, very important simplification which you need to understand. So if both real part and imaginary part have some number in common, so you can take out that number outside and then go for small complex numbers and multiply them. So I hope you have understood the concept of multiplication of complex numbers. So next we look at the operation of division. So how do we divide two complex numbers? So let us take an example. So if we are asked to divide 2 plus I divided by 4 minus I, or 4 plus I for now. So you're asked to divide 2 plus I by 4 plus I. So you don't do it directly. So what we do is, we have a process called conjugate multiplication. So this is approximately same as the rationalizing factor which you use for division of surds. For example, if you have 2 plus root 3 by 5 plus root 3. So if you have this, so how do you divide these two irrational numbers? So what we do is we multiply and divide with 5 minus root 3 and 5 minus root 3, where 5 minus root 3 is called the rationalizing factor. So once you do this, the denominator becomes a rational number 5 plus root 3 into 5 minus root 3. 5 square minus root 3 whole square. 25 minus 3 is equal to 22 in the denominator. And the numerators can be multiplied using the process of multiplication. Here, 5 minus root 3 is called the rationalizing factor for 5 plus root 3. So here we apply a similar process, but the process is called conjugate multiplication. We don't call it rationalizing factor in complex numbers. So what we do is we take 2 plus I by 4 plus I. So we multiply and divide this with 4 minus I and 4 minus I. This 4 minus I is called conjugate to 4 plus I. So let us look deeply into conjugate later. For now, if you have 4 plus I here, we just need to multiply it with 4 minus I in the numerator and denominator. So what happens is the denominator becomes real. So 4 plus I into 4 minus I is 4 square minus of I square. So the denominator has become real. And the numerator is nothing but multiplication. So 8 minus I square, that is 8 plus 1 is 9. Minus 2I plus 4I is 12. That is equal to 9 plus 2I by 4 square minus I square. This is where you get a difference. I square is minus 1. So you get 4 square minus of minus 1 is 4 square plus 1 is equal to 17. So 9 plus 2I by 17 is the answer. So 2 plus I by 4 plus I is this. So let us take another example. So I minus 5 by 4 plus 5i. So if you want to divide these two, you multiply the numerator and denominator with 4 minus 5i and 4 minus 5i. So what happens to the denominator? 4 plus 5i into 4 minus 5i is 4 square minus 5i whole square. And the numerator becomes, so what is the real part? Minus 5 into 4 is minus 20 minus 5i square. Minus 20 plus 5 is minus 15. And what is the imaginary part? 4i plus 25i, that is 29i. So you have minus 15 plus 29i divided by 16 minus 25i square, that is 16 plus 25. 16 plus 25 is 41. So the division of I minus 5 by 4 plus 5i is minus 15 by 41 plus 29 by 41 times I. So I hope you have understood the operation of division. So in division, we use a process called conjugate multiplication, and conjugate looks similar to what you have done in irrational irrational division or third division. So if you have a complex number of the form x plus iy, the conjugate will be x minus iy. So if you multiply these two, the number would become a real number, and in the numerator you can multiply the things and get the answer. Thank you.